To start off today, we've got the Earth's layers, interior atmosphere from the Earth Surveyor. We live on top of the crust, in it we know we can trust. The magma the mantle is made of, it's the outer core the mantle lays above. It's liquid iron, the outer core, you want more facts, just ask me more. It's solid like a horse, it's the inner core of course. Convection's really neat, it moves around the cold and heat. They appear when it's cold, they're clouds, how bold. When you're outside having fun, the ozone layer protects you from the sun. We breathe it in, it's the atmosphere for the wind. Do you have scoliosis? No, it's just Coriolis. Seismic waves were used to discover the Earth's interior. It was because our available tools could not get that far were inferior.
Triangulation is a formation. We use circles to find the location. Be careful when you feel the earth shake. Seismic waves will cause an earthquake. If the ocean's gone, start to run. It's an upcoming tsunami and it's no fun. Divergent boundaries involve two plates. They go their separate ways to their fates. Watch the two plates collide. It's convergent, but it could subside. The Richter scale grows by tens. Rate its magnitude, there's no end. Hey, did you feel the ground shake? I think it might have been an earthquake. What would you rate that on the Mercalli scale? Do you think it's a 10 or a 1? Explain in great detail. When plates slide across the edge of one another, it's called transform. They don't want to touch each other. High in the sky, rose from the ground. It's a mountain, they're easy to be found. Seismographs are installed underground. They detect movement from all around.
First, we got igneous rocks that are formed in volcanoes, makes up 15% of Earth's land, survey shows. Next is silica, and it's a little like a bead. It's a molecule that can be found in seaweed. We have a caldera which has a crater so gigantic, the eruptions in it would start a massive panic. We know a volcano is an opening for gas and debris, and it also erupts and goes on for miles to sea. Then we have a hotspot. It's an oceanic region where heat is brought. Viscosity is sticky and thick like glue, and is resistant of fluid in our point of view. Road eruption means the eruption's underway with hazardous activity, so you better get away. Gray eruptions are different and often explosive, so clouds they produce are often corrosive. Relative dating focuses on rocks both young and old and determines their age on what the information is told. Last but not least, magma takes longer to cool, but lava's consistency is more like water in a pool.
Next, there's extrusive rocks, cool on the outside. They flow down the volcano, small crystals are implied. On the opposite end, some rocks are intrusive, they're trapped inside, you could say they're reclusive. Sedimentary rocks form from layers of fallen material, other rocks are maybe dead organisms, bacterial. When Earth was formed, there was only one continent. Its name was Pangaea. Read it, 3 consonants. Supercontinent spread, anything but swift. This soon became known as the continental drift. Alfred Wegener was born in Berlin, Germany, and to us, his story is cemented eternally. Alfred Wegener soon made a groundbreaking theory all about how through plate tectonics our continents came to be. Wegener spread his ideas just like the sea's floor, but to expert scientists, his ideas seemed poor. Alfred ran home, in defeat he cried, and sometime in 1930 he died. It was Alfred Wegener who started it all. Tectonic plates were only discovered because of him, y'all. Finally, it's time for seafloor spreading, which means it's to the ocean where we are heading. It starts with subduction, underground we're driven, old floor melts, a trench forms, we now have ammunition. To the mid-ocean ridge, the material is given, it rises again to complete its mission. Drawing near to the goal, it pushes away the old floor subducts, as mentioned before. Over and over again, rinse and repeat, this rap is finally over, we're done, we're complete.